everybody. Welcome to another episode of Platformers. My name is May Baseron, and I am happy to have here this amazing rock star of a person. She has a name. Her name is Hila Fish. But other than being a rock star of a person, let's talk like what's going on here. So, Hila Fish is an AWS Community Builder, and she's a HashiCorp ambassador, and she's going to talk today to us about OpenTofu best practices. And the way I know her, she's going to give us the best things ever possible, and it's going to be actionable and easy to understand. Now that I've raised the bar so high, Hila, what's up?
I'm good. I'm good. How are things? As much as possible, because I know Israel is not that fun these days.
Everything is okay. Don't worry about it. Let's concentrate on having a good time. So, how do you want to do this? Are you going to start now, or are you going to start in 2 seconds from now? Which
Uh,
one is it going to be?
yeah, I mean, I'll put my screen now, and then you can just do the put it on the stage, and then
With
I'm gonna be
magic.
ready.
Okay, awesome. So, yeah, just so everyone will know, once you have any questions, and I'm sure you have lots, because it's a great topic, then you can post these in the comments. I will try my best to read most of those questions. And for those of you who I won't get to their questions, I guess you can reach out to Hila. I just volunteered you, but I know you. I know it's okay. So yeah. How about you take it from here? What do you say?
Cool. Can you see my screen?
Not yet, but
I think that you need to do like a
yeah, there you go.
or something like that.
There you go. Now we can see it.
Awesome. Okay, so today we're going to talk about Terraform practices to enable infrastructure scaling, Terraform / OpenTofu. I'm going to say just Terraform, but I'm referring basically to both. Is an awesome tool for infrastructure as code and anything on this realm. And as such, there are things to be mindful about that. We need to have some best practices when we use it. We need to avoid pitfalls. We need to think about it when we think about scale, because we shouldn't do it just in an ad hoc manner, but actually think about it before we actually jump the gun and start working with it. So in this presentation, I'm going to share with you some tips and best practices about using Terraform. So you hopefully will think about it more than just an infrastructure as code tool. So first of all, a little bit about myself. In my profession, a senior DevOps engineer. I have more than 15 years of experience in the tech industry. I'm basically a DevOps culture fan, because I think that DevOps culture helps companies achieve great things. As May mentioned, I'm AWS Community Builder, a HashiCorp ambassador, because I talk about Terraform and also lately Vault in a lot of conferences. And speaking of conferences, at the end of the month, we have DevOps Days. I'm a core organizer. So if you are based in Israel or you want to visit, so 30 and 31 of October, we have DevOps Days. It will be awesome. The agenda is live and you can join us. Yeah, so let's start. So first of all, a short disclaimer about the presentation. Again, this you'll see Terraform all over, but it applies also to OpenTofu. I assume I didn't use OpenTofu, but since it is a fork, it should be applied as well. Most of the examples that I'm going to share with you here in this presentation is from the AWS provider, but of course, Terraform works with all cloud providers out there. And also, the presentation is about Terraform open source. I mean, not cloud, not enterprise. So the open source version, or some sort of open source, the BSL version. So have that in mind as well. So first of all, let's talk about quick wins. When I say quick wins, I mean things that you can achieve basically in a matter of minutes that will help you in the long run when you work with Terraform. So first of all, versions lock. So same as if you are a developer and you lock versions of Python in requirements.txt or package JSON lock in other languages. So same idea goes here. We can lock our models, providers, and Terraform itself, they're all versions. So you can see here in the examples how I lock a version of a model, of a provider, and Terraform itself. And why do we need to lock versions? Because this is a meme by Anton Babenko. I consider him as a Terraform celeb. He's one of the main maintainers of Terraform AWS models. So as you can see, DevOps engineer wants to manage everything as code, and then Terraform AWS provider issues comes in the way and not always letting them do what they want. So if you lock provider versions, at least you deal with the devil that you know. So you will face a lot of issues if you wouldn't lock the version. So if you do lock it, then at least you'll know the constraints of the versions, the limitations, and what to avoid, and you'll have a scope for that. So the good thing is to lock models, providers, and Terraform versions. The bad thing is to lock in a way that will still allow breaking changes to occur. For example, if you lock to a minor version and not a major one. And the ugly thing is to have no versions lock whatsoever. Trust me, it could get nasty. So that's about that. Second up is tagging resources. So we can tag all the resources that we create in the cloud. These are some examples of tags that you can use. And the thing about AWS specifically is that in the provider itself, you can have and you can set something called default tags, meaning that all tags that you set there will get inherited for all resources that you create for this provider. So for example, it doesn't matter, I create EC2s, autoscaling, EKS clusters, whatever. If I set up default tags of managed by Terraform, then automatically all the resources will get this tag. It is great because it avoids us to repeat ourselves. We don't need to put those tags over and over again in all of the resources. And it's like you said it once, forget about it, and that's that. So managed by Terraform is a very classic usage for a default tag, but if you have anything else that you want to set up that makes sense to you, go for it. So the good thing is to tag everything that you can. And why is that? Because consistency is key. And if you don't have consistency, it will be very hard to track your project, to track the costs of your projects and your infrastructure. And then the FinOps team will be a bit upset with you. And if you don't have a FinOps team, congratulations, you are the FinOps team. So try to avoid not tagging stuff. Use default tags as much as possible, and even PR enforcements, which is something that I will get to at the end of this presentation, meaning that I can set up some checks to make sure that if something doesn't happen, the PR wouldn't be able to be merged. So in this case, you can have a PR enforcement that if someone in the PR didn't add tags, then the PR couldn't get merged until this person will do another commit and add the tags to the PR. The bad thing is to tag inconsistently because, again, consistency is key. And the ugly thing is to have no tagging whatsoever. Trust me, not good, very hard to track costs. Even if you use other tools like a Datadog, they rely on the tags. So really not a good thing. And the last section in the last thing about in the section of quick wins is remote state. So by default, Terraform works with remote state, with the default state, which is not good because if you work with other people, if you want to avoid setting up permissions for your user, etc., you want audit on whatever you're doing. So remote state is always the way to go. You can have backups, and you can secure it, etc. So this is how you set up a remote state in AWS. But of course, again, you can set up the remote state in a GCS bucket, in GCP, etc. So it is a very important aspect to take care of. So the good thing is to have your state remote and secured. Make sure the state is backed up. You can enable S3 versioning for that. And also you can have Terraform state lock. You can achieve it by leveraging DynamoDB, or you can even, if you use an open source tool called Atlantis, then it takes care of it for you. And I will mention Atlantis in a bit more in depth later on. The bad and the ugly is to have local state, because again, no audit, you need like local credentials, and it is more easy to mess up your state that way. Another bad thing is to have the state remote but not secured or backed up, because then if you need to restore it, it will be not good. And if some stuff will leak out and some things are kept in clear state in the state, then we shouldn't want them to get to the wrong hands. And if the state is not getting locked during apply or destroy, then it's also not a good thing, because conflicts could happen. Okay, so I said that I thought that maybe I would do like a short stop before each section if there are any questions. So before I continue to the next section, May, are there any questions until now?
Yes, one question. So what could be some additional use cases for tagging? Why is it good? Is there any other reason than just not, I think not just, but okay, whatever, than just, having monitoring on cost? Yes.
Okay, so cost is one thing. It is important. I think it's one of the most important things when we deal with the cloud. But setting this aside, it's good for tracking a logical arrangement of our projects to know which resources belong to which project, and then we will know not only cost-wise but also generally speaking, like, okay, I didn't know that we need the DynamoDB for this project. Why? Maybe people don't know about it, and then it will help them actually to understand the flows of the application because of the tagged resources. So this is one. And as I mentioned before, if you use tools like Datadog, then they actually rely on tags for some of their operations. So this is another reason.
Okay. All right.
That's it?
Yes.
Cool. So the second section, basically second out of three of this presentation, is second nature. So second nature are basically things that you should think about in your day-to-day while you work with Terraform. So that way it will help you work and utilize it in the best way possible. Think long run, avoid refactoring, etc. So first of all, using community models versus creating them yourself. So there's a saying, why reinvent the wheel if the wheel already exists? Saying goes here, if you have basically a use case that is already covered by a community model, as I mentioned, there's Terraform AWS models by Anton and two friends of him and of his, and for GCP, there's also a Google models as well. So if there are already models that are basically used by millions of people and they fit your use case, why create models yourself if you can use them? Because they are basically maintained every day. They make sure that there's documentation. They make sure that all new features are getting covered. So it is a great thing to do. So use community models whenever possible and when it fits your use case. So community models that you should use are basically one that you verify. Once upon a time, in the Terraform registry, they called it signed community models because HashiCorp themselves basically approved and verified them. Now they removed the signage, and then you should just verify it by making sure that the number of downloads are very, very high, and then that way you know that they are safe to use. The bad thing is to create a custom model, but if you still maintain it as a community model, making sure that there are checks, tests, you have them up to date for all the features, etc., then it is still quite okay. And if you have a community model but you don't lock the version, then it could get ugly because of the things that I mentioned at the beginning. And the other thing is to have a custom model and not maintain it because it will get obsolete very, very quickly, or not. Or if you want to upgrade to a different Terraform or OpenTofu version, it might get even incompatible at some point. And using unverified community models is also another good thing because it could potentially introduce malicious configuration to your code base. And if you do have to create your own models, make sure you make them stateless and clean as much as possible. So make them generic, do not repeat yourself. If you don't have to, keep them as simple as possible, and use enforcement to maintain the quality. And again, I will get to the enforcement part at the end of this presentation. Okay, let's talk now a bit about variables versus locals. So variables are basically the settings that you have for your resources or for your models, and then locals are something that you set up that doesn't get changed during Terraform implementations, like doing a apply or a destroy. So when should you use locals? For example, if we want to set up like a final definition of tags, so I can have a variable of project name, environment, and then on the local side, I have required tags, which is the combination of project and environment, and the final definition of tags is a merge between the required tags and maybe some resource tags that I have separately. And that way, it doesn't matter what I try to do, what I try to set up or not something, it gets calculated once, and then it gets have this final definition throughout whatever apply or destroy that you do for the model or for the resources. So when we talk about variables on the model side, so of course their purpose is to be some sort of settings for the model configuration, but make sure that you use and you set a default or validation, as you can see in this example here, because if not, and someone will use this model, then it will break because they didn't pass the necessary variables, or they pass some wrong inputs. So you should make sure that you get exactly what you need in the model side. And on the model side for locals, you can think about them as a constant to be honored or relied on. So for example, if I do decide to not use the community model for S3 bucket, and I create a one by myself, I can set up a local for a bucket name that will be basically comprised of the company name, protected, whatever. And that way that if and anyone that will use this model will automatically have to and basically be bounded to this convention, and whatever a bucket that they will create, the name will be in this convention. So it is basically a constant that is to be relied on. And in terms of buckets, it is important to have consistency in the naming because buckets are unique throughout the entire cloud. So it's a good thing to set up. But again, this is just an example. You can think about it in other way. Just make sure that you think about it as a constant to be honored or relied on. And on the live side, and when I say the live side is where I use the models. So if I'll talk to the developers of you, a model is a class, and then the live side is instantiation of the class. Same goes here. Model is the bunch of resources that we have, and then the live side is where we actually call the model. So on the live side for variables, if we use them once, let's use just a default and that's it. If we use them per region or etc. or anything else, then we can use tfvars file. I'm not going to touch here about TerraGrant, which is basically a wrapper for Terraform or OpenTofu. But if you don't use TerraGrant, you can use tfvars for any variables changes that you need to do per region or anything else. And on the live side for locals, you should avoid using locals as much as possible because we want to leave the logic for the model side. But if you need to do that, then you can do it, but try to leave the logic for the model side. And try to use data sources to pass outputs for the models, because that way you get dynamically and real-time information about whatever you need for the models, and then you know it is up to date. So to sum this mini section up, use TFVars where necessary when you have different regions, for example. Utilize environment variables, which is something that you can also do, because then it will eliminate the need to add more variables because you have like out-of-the-box variables because they are environment variables. Use locals to dehard code in one-time names and decrease code repeatability. And in general, try to keep things as generic as possible. The bad thing is to have, for example, multiple local blocks if not necessary. Terraform and OpenTofu allows that, to have multiple blocks, but it burdens on the eye, and it could be confusing, like what why is it splitted? So if you don't really have to split them to different blocks, don't do it. Decentralized vars, same reason. Don't scatter all your variables. Have them in one file, and I will talk about the file structure in a second. And ignoring advanced variables, because we can use them and avoid adding more variables to our code base. And the other thing is to have hard-coded variables values when we don't really have to, because that's the thing about variables. They need to vary or vary. I don't know how to say it in ish, but that's it. So just if you don't have to really hard code them, don't do it. Okay, let's talk now about file structure. So as you probably know, Terraform or OpenTofu basically applies Terraform or consider the code whenever the suffix is TF, but we need to have some sort of logical arrangement of the files for us human beings that need to manage them. So we can take example from the community. So in the community modules, we have main TF for the main logic of the module, and then variables for the variables, data for data sources, and then versions for any versions of the Terraform and providers. And if we need, for example, let's take a model that creates a VM, okay? So the creation of the VM will be in main TF, but if we need other peripheral things like a load balancer or security group, then we can put them in separate files with those names so we know exactly what they are about. And if you are creating basically a custom model, then you should think about splitting the model if it is complex to submodules. Because I'll give an example, for EKS module, they have a submodule of node pools, and for a VPC module, there is a submodule of VPC endpoint. And why is that? Because I probably want to create a cluster in that region only once, but then maybe create more than one node pools. And that way I can call the submodule again and again without calling the entire model. And also, if I have a submodule, then it has its own set of variables, and that way we don't have a gigantic variable file that we don't know what goes where. It is split up, and then we can manage it better. So if you have a module that is complex, try and see if it makes sense to break it down to submodules. Okay, this part I really like to talk about, applying classic code best practices on Terraform or OpenTofu. Again, I told you I'm going to say Terraform because I'm used to it, but it should get applied to OpenTofu as well. So I don't think that anyone here that watches thinks that Terraform is a pure programming language. I don't think that anyone thinks like that, but still, classic code best practices can be applied on Terraform. So what does it mean? We should keep the code in source control management, of course, GitHub, GitLab, Bitbucket. The code should be as simple as possible. The code should be human, readable, and clean, meaning that whatever we write, we can sometimes use a one-liner, or we can have a very complex condition, but you need to remember that people are the one that needs to manage this code. And the computer itself will execute it if the syntax is valid, but we need to write code for people, for them, and for your team, for other teams, for your developers that maybe you will use the models. We need to write the code in a way that will make sense to them, that will be easy for them to manage and maintain in the long run, and not after a year that someone wrote something and they will say, wait, what is that? I have no idea what's going on. And even ChatGPT can't decipher it. So make sure you write the code in a human and a clean manner. Do not repeat yourself if you don't have to. Even functional programming aspects can be applied on Terraform. And of course, the code should be idempotent. And that's it for the second nature section. Any questions until now?
Yes. I do have to say that I really like the last part. Just said it, put it out there. Okay. So we have one question here that says this way: when choosing AWS provider, what are the pros and cons between first HashiCorp slash AWS, the original, and HashiCorp AWS CC Cloud Control version?
So I didn't use much of the latter. I did. There was one feature that wasn't exist on the regular AWS one, and then I had to use the AWS CC, and that's the reason why I used it. But other than that, I have no idea what are the difference between them two. I would just read the documentation and check it out, but I would usually probably use the one that is more maintained and more used by other people.
Sounds good. Okay. Wade, there's another question. After that, do you have recommendations for automated Terraform provisioning pipeline with GitHub Action? For example, DevSecTop or TF via PR.
I would say it taps into the last section that I'm going to share, even though it's not purely about pipelines, but it is doing the PR creation. So let me cover that one. And then if then the question didn't get answered yet, then I will try and give more inputs about it. Cool?
Sounds like a deal. Let's get to it.
Cool. So the last section of this presentation is long haul. What does it mean? It means that these are the things that you should really think about and plan ahead before you start to work with Terraform specifically, or before you're doing a major refactoring or something like that. So you need to think ahead, and these are the things that you should plan before you dive right in or do any major changes. So, and it's actually, okay, I don't remember this slide in, but I will cover it as well. The reason why we need to plan ahead is because we are not doing things just because. We're not creating infrastructure just because. We're doing it for the sake of our company, for the sake of the applications and what the application needs, right? Because infrastructure doesn't exist for nothing. It exists to serve the applications. And why do we need applications? Because it serves the main logic and the main business of the company. So always envision the companies and the infrastructure needs before you dive ahead when working with Terraform or any other tool for that matter, actually. And that way you will make sure that whatever use cases, whatever needs that you really need will get addressed during the planning phase and then the implementation, because it's super important. I saw a lot of people, companies, etc., that just dive right in and do things before planning, and then during the actual implementation, they say, okay, I didn't think it will behave like that, or I actually need X, and then something else happens. So we really need to make sure that we have the infrastructure and the company's needs in mind before we do anything, and specifically in this presentation, before we structure or refactor Terraform. So talking about Terraform codebase, how do you structure a Terraform codebase? So there basically are a lot of ways to structure a Terraform codebase, and I want to share with you here one structure that I used in one of my previous companies, and why we used it, and how it served us very well. So this is the structure that we had: a team, project, cloud provider, account or environment, and then region. How does it look like? Like this. So we have the models, and the models, the custom ones, were on the same repository. And then on the live side, we have BI for team, Airflow for project, AWS for cloud provider, production, dev, whatever for account or environment, and then use this one for region. That was the structure that we had. And as you can see, we have team, meaning that we had one single Terraform repository for the entire company to use. So why this structure really served us well? Let's see. No, it's not great. Okay, I didn't remember. It's not an up-to-date version of the slides. Never mind. I will say it not by heart, by verbally. So it is somewhat covered here. Okay, never mind. I'm good. Okay, so this structure serves us well because the states are very small in this part, because if we will look about on the structure here again, the state file of Terraform is kept there in EUS East 1, meaning it is very, very small. It only consists of Airflow resources or Airflow related resources for the BI team in AWS production EUS East 1. Very, very small, and it's super important because of how Terraform works. Terraform has and always creates dependency tree. And when there are a lot of resources in the same state, sometimes Terraform creates invalid dependencies, meaning that you can potentially find yourself changing one bit, then running a Terraform plan, and then you'll see that the plan output shows something entirely different from what you tried to change, and that happens because of invalid dependencies. So in order to avoid a matter of invalid dependencies, have a structure. I'm not saying that you have to, of course, choose this structure, but at least have a structure that makes you or compels the code to have small state files, and that way it will eliminate the probability for big blast radius for invalid dependencies. So this is one reason why we chose this structure. The other reason is Terraform as a platform. So as I said, the entire repository is basically serving the entire company, which is great because, first of all, if there's a new team, they just onboard to the same repository, add a new team folder. We have code owners, we utilize it, and then we give them permissions, and then they can manage their own infrastructure, and that's that. And then out of the box, they get the checks that I'm going to share a bit here, the PR enforcements, basically checks that make sure that the code is in a high quality state, and other internal checks that we want to make sure that are applying. And also the custom models, because when we create custom models, we make sure that they are generic. So if they are generic, everyone can use them. So once a new team or any team wants to use models, for example, they can just use the ones that are in the same code base, and that's it. Everyone are happy. So that's why I call it Terraform as a platform, because anyone can use it. They onboard to this repository, and then they can leverage everything inside, the checks, the models, etc. So the good thing of really planning ahead when you structure your Terraform code base and making sure that your use cases and how you work applies and gets implemented in the structure of the Terraform code base is that it will allow you to set up small state files and to preferably have Terraform as a platform. The bad thing is that if you don't plan ahead, maybe organizational changes could make you or force you to restructure your code, which is not great at all. And also something that I didn't have much to cover, didn't have time to cover in this presentation, wrong workspaces usage. Workspaces is something basically a feature that allows you to have use the same Terraform code, and then the state files are encapsulated in different workspaces, and then you switch between them. And how you switch them with CLI, so that's why it's a bit problematic to use workspaces in a vanilla way. But just make sure that I'm giving you a bit of homework. If you do want to use workspaces, make sure you read about it some more, and make sure you use it for the right reasons, of course, because if not, it could be very problematic in the long run. And the ugly thing is that if you don't structure the Terraform code base in a way that will have small state files, you will definitely have invalid dependencies when you have a huge state, big blast radius. You'll do one change, you'll see in the plan output different bunch of stuff that you didn't plan to do. Very hard to deal with it. So please avoid that and have a structure that will create small state files. Let's talk about Terraform execution. So a good thing is to have to do a remote execution. That way we don't need local configuration, local credentials. We have audit of whatever we are doing. So it's always a good thing. And one of the ways to have a remote execution is by leveraging Atlantis, as I mentioned before. Atlantis is an open source tool for Terraform pull request automation. So whenever I did the changes, I opened the PR, and then Atlantis will which is basically gets integrated in GitHub. Then it will, once you open the PR, it will run a Atlantis plan, which is basically a Terraform plan. It shows you the plan output. If all is good, you run Atlantis apply, and then it will both apply your code and basically merge the PR if everything got applied okay. So it is awesome, a good way to have remote execution. It also handles the state lock. So if someone else opened basically a PR that touches the same state, it will tell them, hey, sorry, PR X is currently locking the state, wait for them to finish, and then you can do whatever you want. So it's a good handler for remote execution, for having a team or different people touching the same state. So it is a great tool to use. So that is about remote execution. Make sure another best practice is to do a Terraform apply with a plan file. There's like a flag -- a plan file that you can set up, and then that way you make sure that you apply exactly what you planned to do, that the plan that you actually reviewed. And another good thing is to set up Terraform timeout. I think don't remember what is the default one, if it's an hour or 24 hours, something crazy like that, because I always change it to 10 minutes or 15 minutes. But Terraform timeout is important because I'll give you one scenario that you can think of. Let's say you created auto-scaling group with spot instances, and then the price that you set up for the spot instances are very, very low. Then it will wait to see if the price will decrease, and then it's just a waste of time. And then this story is actually a true story that once upon a time I did it, and then I didn't want to wait for a graceful abortion of the operation, and then I did Control-C, and then it messed up my state. So because I didn't have backups, because everything that I share with you here is through blood, sweat, and tears. So don't do that. Don't do Control-C, which is basically linked to the next point here, that I executed locally, and then I executed locally and did Control-C on Terraform apply, and not great. And maybe I did it a very long time ago when I just started out with Terraform. Maybe they changed this behavior. Maybe now when you do Control-C doing a Terraform apply, it does get like it sends sick term and it do a graceful termination. Maybe, I don't know, and I really, really don't want to find out. So I advise you to not try it either. So yeah, which brings me back to setting up Terraform timeout that makes sense to you. Let it finish gracefully. And the last section of this presentation that I had a very big build up until this point, practices enforcement. So basically, you can set up any checks that make sense to you, that you want to make sure that are getting checked during whenever you have commits or PRs getting introduced for your code base. So for example, I want to check if the resources are tagged. I want to check if the code is reusable, if it is readable, if it's clean, if the person that created the PR created resources more than $10,000. And then if so, I want the FinOps team to get alerted by it. For example, anything that makes sense to you, anything that you want to check on the code is something that you can introduce as part of the practices enforcement. And I want to share with you here how the community models are actually doing that. So this is a snapshot from specifically from Terraform AWS auto-scaling model, but all of these checks are applied on all Terraform AWS models. So you can see here that the checks check if the contributor formatted the code using Terraform FMT, if they added documentation, if the code that they wrote are actually working, and they check it through with TF-Lint, etc. So this is just an example. You can apply that, or you can apply this and any other thing that makes sense to you to make sure the code is in a high quality state, or to check for anything that you want to make sure that is happening for the sake of the company, the department, whatever that you want to make sure that happens. So you can have pre-merged linters, formatters, and logical checks. You can do it through GitHub Actions or CI pipeline checks to make sure that the PR that gets opened doesn't even qualify for a merge until those checks are passed. You can have or create Slack bot drift reporter to make sure that your code is not drifted from the actual environment. But if you use Atlantis, then you don't need the Slackbot drift reporter, because you know that the main branch equals the actual environment if you only use Atlantis, because as I mentioned, once you use Atlantis, you do Atlantis apply after reviewing the plan output, and then that's it. It applies and the code gets merged to main. So there's no drift like that, because it will always get merged after apply. And the bad and the ugly here is if you don't apply practices enforcement, then you could potentially have security issues or even non-compliant configuration in your code base. And on the right, you can find some open source enforcements and helpers to help you in the journey of introducing practices enforcement in your Terraform code base. So these are some tools about costs, about anything else. Terragant, I put it here just to help you. It's not really about the practice enforcement, but it will help you with other practices like don't repeat yourself, etc. So I put this question here again to remind you that whatever we do, we don't do it just because it's fun or cool, and we don't create Kubernetes just because we want to work with Kubernetes. We do things because we need to make sure that the company needs it, the infrastructure needs it, the application needs it. So whatever you do, don't dive into things right away. Plan ahead, think about it, and make sure you apply it as the use cases needed. And if you take, and I covered a lot of things in this presentation, but if you take only two things, take those two. So code-based structure, structure the code base in a way that will make sense to you and will allow you to potentially have Terraform as a platform, and for sure to have small state files, because you can't have it any other way with Terraform. And practice enforcement to both enable infrastructure and teams scaling, because if you add more and more infrastructure to your company, or you have more teams that create infrastructure, you want to make sure that it doesn't matter how it's scaled, everything is still kept in a high quality. So for that, in order to enforce it, we have to have those checks. And like any other tool, don't use Terraform in an ad hoc mindset. Always plan ahead. Always think about the future needs as much as possible, because we do have roadmaps at least a year onward, but sometimes even more. Always plan ahead and think about it. The fact that if everyone would write Terraform in the same way, I wouldn't even be here talking about Terraform practices, because everyone will just write it same way and be on with our lives. But we will always have different ways to address things. We will always have projects, because what is a project? Moving from one current state to another desired state of project in our company, on whatever goals that the company have. So in order to enable projects to happen in the day-to-day, in order to make sure that we are able to move forward and not be a bottleneck for the company, then we need to plan ahead and use Terraform in a way that makes sense to enable all of that. And these are some references of things that I covered in this presentation. So some about tagging, labeling, some things that you should read about workspaces. Thyssen is a blog post that I read about. It covers a lot of things. One of those things is the human factor when writing Terraform code. So I really recommend you to read this blog post. And you have Superlinter, one specific for Terraform and one for like a bundle of GitHub actions, so you can utilize it as well for your practices enforcements. And that's it. Thank you very much.
All right. So I guess now if we have any more questions, I think that we do have one from the very beginning, so that I would like to iterate back to. And after that, if you'll have anything to add, then we'd love to hear something else from you. But first, can you give some options about hosting remote states like S3 Bucket and DynamoDB or Terraform Cloud?
I haven't used Terraform Cloud, so I can't really address that. In terms of remote state, buckets is the way to go. If you use, let's say, Terraform OpenTofu like vanilla way directly, then just host your state in a bucket. Or if you use tools like NF0, for example, then they have an option for you to host the state file on their end and their backend as well. So this is one or two options. But mostly, if you use it in a vanilla way, just a bucket is the way to go. Make it secured and all good.
And last one, what about using Renovate to update automatically Terraform resources version?
I haven't used it. I would, for like any other thing that I will, that I like read about or hear about it, I will do a POC, see if it tailors and fits my needs, see if the overhead of maintaining it is worthwhile, and if so, so
If
be it.
it's worth the use case, I think that's a good point. Like, I think something that important to say here is by the variety of questions on different options to do things with Terraform, there are so many, and that's because there's so many different use cases. Every company have their specifics. Like everyone generally want to do good, but then right, they have their specifics. They have like cost. They have constraints. So that's why it's pretty difficult to say, in my opinion, this tool is good or bad or something like that. It's more like it's good for this use case, it's less a good fit for this use case. We can make it work, but is it worth the while? Which
Yeah.
is exactly what you said. And with that, I think we'll wrap it up. And we'll say big huge thank you to Hila. It's always a pleasure for me to hear you talk about Terraform and best practices, because as I said in the beginning, didn't I tell you, everybody, like she's gonna give us some good actionable tips. I've been writing some comments during the like while you talk, because there's always something to add. Like you can never know enough. And I think the best thing about what you provided us with here are things from your point of view, from your experiences, and it showed. So thank you so much. And thank you, the audience, for joining us. You're awesome. And we hope to see you next time. Bye.